monolith application is good for something, microservice architecture is good for something, so we will look at it. So, what are microservice architecture pros? Well, if you look at a large application, like many people can maintain these applications. It's like 20, 50 people that maintain these applications. And if you want to like have meetings this large, like with 50 people, it will take so long that it will last forever. So you want to divide like your product or a project into small components, and microservices can help you do that. So what's the pro of microservice architecture is like team organization, or organizing like the logic of the application in a physical way, like separating into blocks. And so it decreases communication overhead because everyone in a team doesn't need to know all about the application. They just need to know the one thing they're working on, and there's a microservice. So what are cons? There are plenty of them, and they are kind of technical. So pros are organizational, and cons are kind of technical because you need to deal with a lot of things when you deploy microservices. And one of the things is you need stable APIs. What does it mean? If you have a product and the product is like in an alpha stage, that you don't know what are the APIs, what will it return, all these things like what it should actually do, like in a result, then you won't be able to establish stable APIs in microservice architecture. And this will cause a lot of trouble in teams because when one team has like one microservice, and second, and something breaks, in one microservice and it breaks, like the implementation of the first team, you're in trouble. So what's next? Hard integration testing. This is because like in monolith applications, you have shared DBs or shared databases. So when you want to integrate, or when you want to do integration testing in microservices, what you want to do is you need to like go across all the microservices. So it's kind of hard work to do when you don't know like all the microservices well, because your teams are actually separated. And what's next is heavy CD pipeline. This is because you don't need to deploy like one wallet. You need to deploy a lot of small microservices, and they need to communicate, and they need to be stable in a way like with uptime. So you need to actually do your CD pipeline in a way that it's deploying all the microservices in a stable way. So the next trouble is service discovery. What does it mean is you have a monolith, that's one application, you get requests, you get, then it responds, that's all. In microservices, you can have one microservice that accepts the request, then requests other microservices, gets response, and then responds. And that's why we need service discovery, because they need to know where are other microservices that they need to use. What about monitoring? So when you monitor monolith applications, you monitor a single application. When you need to monitor like microservices, you actually monitor like 10 applications. And that's also for security. You need to actually secure all the microservices for authorization, what are the rules of that authorization. And maybe the biggest thing that actually got us at our projects is separate DBs. This is because monoliths use like one shared DB, and that way they can do transactions on the same DB. Like you have one component that can take all the things from the same DB. Well, if you have microservice architecture, you need to know that each microservice has its own DB, which means that if you need like, if you're going for an e-shop or something like that, you want a authentication microservice, you want a product microservice or something like that, invoice microservice, and so on and so on. And so when actually users want, for example, a list of like report for a user what he bought, they need to take like information from a lot of microservices to actually get the result. So let's talk about RPC. Real pursuit calls are actually kind of easy because when you write RPC calls, it actually feels like you're calling local functions. Like imagine if you're like if you have like a calculator and you have a function add that adds two numbers that you give it. When you write the code, you write the same RPC code, but what it does is it calls the remote server. So that's what RPC does. It actually feels like you're calling a local function, but it calls it on a remote server or on a remote machine. And what RPC does for you is it solves the data transportation. So this is kind of big deal because when you want to implement like your own data transportation, it will look like you're actually just implementing all the data transportation instead of your business logic, right? So this is what RPC is good for. Okay, so what about protocol buffers say? Anyone here who ever heard of protocol buffers?
Yeah, I've heard about it, but I have no idea what it is.
Okay, good. So protocol buffers are actually binary serialization mechanism. So what it is? If you have XML and you have protocol buffers on each side, well, XML is encoded like this in 69 bytes. It can take 5,000 to 10,000 nanoseconds to actually parse this XML. For protocol buffers, you have the same thing, but it has 28 bytes, and it takes 100 to 200 nanoseconds to parse. So why don't we use it? Why don't we actually use protocol buffers instead of JSON and XML and all this stuff? Well, that's because web applications can't speak like protocol buffers. There are actually like experimental projects for WebSockets and all this stuff, but they are kind of experimental for them. So the one thing is that it's hard to decode by human eye. So if you ever get a situation that you actually open the debugger in Chrome or whatever browser you have, and you've gone through the request, you wouldn't be able to actually like see through the request and see the request and the responses and all this stuff because it's encoded in binary format instead of text format. Okay, so like it's like pretty similar. You have a schema in XML and you have schema in protocol buffers. So protocol buffers just do all the serializations for you. And if you look at protocol buffers, it's not just like it has a serialization, but it also has plugins or extensions. So you can actually extend like this schema into this schema, which has like some more properties. This is because protocol buffers support more languages. So if you want to use Java, you can use Java. If you want to use C++ or Go or Python or whatever you want, you can use that. And because of that, there are many extensions that you can use because Java has its packages and Go has its tags and so on and so on. There are like language-specific features, and that's why protocol buffers actually has extensions. So you can actually extend like your definition of protocol by using extensions. So here you have like Go, right? So you can have like field 1, but a JSON tag you add to the generated code is my field. So you actually rename the JSON tag within the generated code. One thing that protocol buffers do for you is they actually generate code. So they generate code for your marshallers and unmarshallers, so you can just give it like structure and tell it, okay, give me bytes, or give it bytes and tell it, okay, give me structure. Okay. So what is gRPC? Like this was all the introduction, and it was because of gRPC. And it's because gRPC actually uses protocol buffers, and it uses RPC. And it supports microservices. So what gRPC is, it's a high-performance open source RPC framework. And what it can do is, as I said, you can actually you can have these definitions in many languages. So you can generate code for many languages like Java, Go, and so on. So you can have like Go server, and then you can have Android application, and then you can have like your web application, which will actually support HTTP, will be activated. And many more like clients, like Ruby, C++, whatever you want. Okay. So if you ever implemented some client for a server, you know that you need to actually implement all the, for example, HTTP calls. You have an HTTP server, you need to implement all the HTTP calls in every language you want, like Ruby and this, and you have Swagger and these things that help you actually generate code based on the API. But you need actually some extra work for each of the generated code. Well, with RPC you actually don't. So if you have gRPC server, it actually generates stubs, and the stubs are actually interfaces. So what interfaces does for you is the thing I told in the first place, and it's that it feels like you're calling local function, but you're actually calling a remote function. So how does it work? gRPC has its own protobuf extension, like all the extensions we heard about. And with this extension, you can see this part. It's actually the same as we've seen with protocol buffers. And then you have this part, and there is the actual service definition. So by this definition, you define a service called calculator, and it has function add, and it takes add request and it returns add reply. Easy, right? Okay, so add request looks like x and y. These numbers are just field indexes. So it's field 1, field 2, and then you have reply that has response. What protocol buffers generates for you is something like this. And this actual interface that you need to implement the gRPC server in your language. This is actual Go. So it generates for you the interface that you need to implement to support this protocol buffer schema. There's actually a lot more code, but you don't want to see it. So let's implement it. As I said, RPC is a procedure call, and it's easy to implement. So what you want to do is you want to take that interface and implement it. So you want to define your structure and then implement the sample method that you had. So you had the method add with add request and reply, and it generated this code. So then you take the interface and you actually just implement it. And the implementation is easy, because what you want to return is you want to just sum these two x and y and just return it. That's easy, right? So, just one question, Matt. Is there anything for transportation layer that you did there? Like HTTP calls or anything? Or servers? Stuff? You didn't. So, there's the power of gRPC that you actually need to focus only on business logic, and you don't need all the transportation layers and all this stuff. You need only the business logic. So what you do then is you actually need to start a server. You start a server by registering the server that you implemented, because it has the interface that we've seen before, and that's all you need to do. Now you start your server, and you can make calls. So the gRPC already created the stub for you. That's where we want to call all the functions. And then all you need to do is you want to dial the remote server, and then you need to do calls to it, right? So you dial the server is where actually the service discovery comes in place, because you won't actually know what IP address there is. So you may something like load balancers and all this stuff. For example, in Kubernetes and OpenShift and all the things. Then you create a client from the connection you dialed, and this stuff can actually just go into the start of your application, and then you just call the stub. It's just like it's just a local service, right? So I just got it add request with 5 and 10, and then it returns in add reply 15. Cool, right? Any questions? Okay, let's continue. So we have gRPC gateway. What it does is, if you have a web server or something like that, and you want to talk with a web client and just translate JSONs into gRPC requests, you actually want to go with gRPC gateway. gRPC gateway, what it does is, it generates your gRPC service. That's what actually like gRPC does, and it actually it also generates reverse proxy for you. So this service can now accept HTTP calls and gRPC calls. What it does it takes JSON, and then you say in the proto you say how it should be translated, like how the JSON should be translated into gRPC call. So you just do this, that's all generated also. Then you start a proxy and it all goes. Then you can speak to web and also to your gRPC microservices. And the last thing is what we found out like 2 days ago or 1 day ago. And then actually it's good to use gRPC with gcloud because it supports all this stuff. It has like the JSON proxy that you've seen, like the gateway. It generates the gateway for you. It's called endpoints, and then you can like get an endpoint. Let's say this endpoint goes to this microservice, and so on and so on. And you then have Kubernetes, and you can scale your microservice up and down with Kubernetes while having all the gRPC stuff there. So you don't need to care about gateways and all this stuff. You just need to care about like your business logic there. It actually supports like gcloud supports Bigtable, PubSub, and speech APIs through gRPC. So you can look at it if you want. And that's all from me. So any questions? Okay.
Is there any way to use like those cool features from gcloud on APIs?
Like these?
Yeah, like this one. But you know,
Well,
when someone likes APIs a bit more than gcloud, is there an option for that?
okay, so the option is actually the gRPC gateway, because what gcloud does for you is it generates the gateway. I'm not sure if it actually uses the gRPC ecosystem gRPC gateway, but it does the work, and it creates the reverse proxy for you. So this is where you need to actually just define the translation between JSON and the gRPC, and then you're good to go. So you can actually generate all the stuff like from this side.
Are you using this at your company?
Yes.
And mostly positive?
Well, we had a hard time for the first time, but then it was okay.
And you think it's worth it?
It's worth it if you have enough time to actually learn everything about Kubernetes and all the cloud stuff there.
And how are you dealing with the integration testing?
We're doing integration testing the hard way. So we're actually like we have the end-to-end tests for everything, like what is business critical. So that's how we do it. We actually call the gateway and see if everything is okay.
So the actual production services you're calling within the integration tests?
We're not like we have the production server. It's not the production. It's like the staging server, or the testing server.
Okay.
Yeah. You actually need like a lot of unit tests for microservices also.
Are you able to somehow adjust the generated code? Is it like
Well, what protocol buffers generate, you shouldn't edit like the code that it generates, but it generates mostly interfaces and marshallers and all this stuff, so we can extend the code. Okay, so
Can I write like, you know, another microservice in another language, like Haskell or something like that,
I'm
and
sure
connect
Haskell.
it through the gRPC protocols?
I'm not sure if Haskell is.
Yeah, it has gRPC.
It has gRPC.
Yeah.
Okay, then you can.
Okay, cool.
Okay, so thank you everyone.